Hello, everyone, and welcome to Calculus. Today, we are going to be studying the separation of variables and exponential growth and decay. So you may remember that in derivatives, we had explicit differentiation, where a formula was expressed explicitly in terms of y. And then we had implicit differentiation, which we used when there was a y intermixed with the x, and you had to deal with it that way. In this case, that does not exist in integration. In integration, you have to separate the variables. There's nothing implicit that you can do. So on this first one, it says dy dx is equal to negative x over y. So what I'm going to do is I'm going to multiply both sides by y to put the y with the dy, and I'm going to multiply both sides by dx to put the dx with the x. So now these y's cancel, and these dx's cancel, and I get y dy is equal to negative x dx. Now I can integrate both sides, and I can integrate the left side with respect to y, because I see an integral symbol and a dy. So I make this y squared over 2. This side I can integrate with respect to x, because I have a dx and I have the integral symbol. So I get negative x squared over 2. Now, of course, you're used to adding c, but I can't add c to both sides because that would just cancel each other out, and then I would be adding nothing. So let's go ahead and add d to this side. Of course, that gets a little complicated. Okay, don't write this next part down. Just watch. So I'm going to try and get y by itself. So I'm going to move the d over. Well, I don't really need to say c minus d. I don't know what either of those variables are anyway. So why don't I just call them e? Well, maybe not e, because e actually has something. F. Doesn't really matter. The bottom line is, whether or not you add c to one side and d to the other, or just add something to one side, do you see how it doesn't matter? Because if you add it to both sides, you can just put it together and still just say you're adding yet a different constant to the other side. So the mathematician's solution to this is to not do this at all, hence my saying don't write it down. Instead, we're still just going to add c, but only to one side. If you add it to both sides, you'll cancel it out. All right, so my goal is still to get y all by itself. So I can either do that now, or I can plug these in now to find c. It doesn't matter the order, but I'm going to go ahead and plug in first. So let's find c. So 9 over 2, I'm plugging these in, and negative 16. Remember, that negative is not being squared. Order of operation says exponents before the negative. So negative 16 over 2 plus c. I'm going to add the 16 over 2 to the other side, which gives me 25 over 2 is equal to c. So it may look like you've reached your final answer, because usually when we find c, we're done. But in this case, you must solve for y. So my first step is to clear my fractions. I'm going to multiply through by 2. I get y squared is equal to negative x squared plus 25. I'm almost there. And y is equal to plus or minus the square root of 25 minus x squared. Now, I can't actually leave it plus or minus, because that wouldn't be a function. I don't know if you recognize this. Let's maybe just change it around a little bit by putting the x squared over with the y squared. Do you recognize it? It's a circle. So when I say y is equal to plus or minus, I'm showing both the top half, that's that square root of 25 minus x squared, and then negative square root of 25 minus x squared is this half, which wouldn't pass the vertical line test. So I'm trying to find just the one I want, the plus or the minus. Well, how do you know? Because y is equal to 3 when x is 4. So if I plug a 4 in, So which one do I want? Well, when I plug a 4 in, square root of 25 minus 16, I get 9, which is 3. So I do want the positive answer. So I'm going to erase that, and I definitely want the positive answer. Okay. So what's happening here is that this is a derivative that relies on both x and y to get the answer. So now that I know it's positive, I know that it's this function right here. I'm going to go ahead and give it a little axis. This is 5, 5, 5. So when y is equal to 3 and x is equal to 4, that has a derivative. What is that derivative? Negative x, negative 4, over y, 3. That slope right there is negative 4/3. And we went back and we found the original function for which that derivative is true. We're integrating. But both y and x matter, just like it did in implicit, where you can't just say when y is equal to 3, because y is equal to 3 also over here. And obviously that's positive 4/3. So it does make a difference whether or not x is equal to 4 or negative 4. And that's why the derivative has both an x and a y value in it. Okay, these problems are very straightforward. You just have to separate the variables and then do the derivative. So number 1 showed you everything that you need to know. So on the outside chance that you'd like to just go for it, you can take a screenshot. I did write down all the answers here, so I'll let you take a screenshot of that. There's no homework on this section. So it's especially important that you do give this a try. But I am going to do all the problems for you. So if there's any problem that you can't get, you can just come back and watch the video. Number 2, whenever, I'm going to say this for every problem, whenever you see an x and a y in the same problem, you have to separate the variables. For people that are in the AP exam, they love this question. You definitely need to be able to do this. So I'm going to multiply both sides by dx. That gives me dy is equal to x. I'm going to change this, of course, to y to the 1/2 dx. And now I need to get rid of the y. So I'm going to divide both sides by y to the 1/2. I am going to integrate in a minute. So I'm going to go ahead and switch this to y to the negative 1/2 and x dx. Now that the y's are with the dy and the x's are with the dx, that was the first step, separating the variables. And when this is an open-ended question on the AP exam, they give you 2 points just for correctly separating the variables. So as you can imagine, it's about to get harder. All right, so integrating on this side gives me y to the positive 1/2 divided by 1/2. I'm not going to write plus c. I'm just going to do that on one of the two sides, over 2 plus c. I am going to simplify this just a little bit, and I'm going to flip and multiply. So this is 2 square roots of y is equal to x squared over 2 plus c. I'm going to go ahead and plug this in. So 2 square roots of 1 is equal to x squared over 2 plus c. So c is equal to 2. So 2 square roots of y is equal to x squared over 2 plus 2. I need to get y alone. Get y alone. And since we're writing notes, separate the variables. Okay. Separate the variables. And then get y alone. So I am going to clear my fractions. Always clearing my fractions. You might think that's making the y more complicated, and it is, but it was worth it to me. So this gives me x squared. This isn't a squared. This is times 2. Maybe I should just write that a little lower so nobody gets confused. Times 2 And that gives me x squared plus 4. So now I have the square root of y, divide everything by 4. I can just leave it x squared plus 4 over 4, or x squared over 4 plus 1. Either one's good. And then as my last step, I'm going to square both sides. So square both sides. So my answer is either x squared plus 4 over 4, the quantity squared, or, and I think this is the one that I wrote on that last page, x squared over 4 plus 1 squared. Both answers are great. Okay. Right, that's number 2. Again, I can't encourage you enough. You should really try each one on your own and then just watch the video if you can't get it. So my first step is to move the dx to the other side. That was terrible. Dx. And divide both sides by the y squared. So on this side, that gives me dy over y squared is equal to 2x dx. I am going to move that to the top. Okay, there's no quotient rule in integration, so you just want to attack it like this. With integration, if you would like to ever move a constant outside of the integral symbol, that's always okay. And this gives me y to the negative 1 over negative 1 is equal to 2x squared over 2 plus c. I am going to switch this around. The negative can go on the top or the bottom. So it's important that you know all I'm doing is making this top negative, but then I'm at the same time moving this y to the negative 1 to the denominator. So it's a little tricky. All right, I am going to go ahead and plug this in. So you always want to find your c. So let's see, we have negative 1 over 1 is equal to 1 squared plus c. That's negative 1, so c is equal to negative 2. And then as a last step, I go ahead and I plug it back in. So this is now going to have the c in it. So negative 1 over y is equal to x squared minus 2. But again, you are required to solve for y, even though it's your variable. Okay, I just want to say this is where people go wrong. Even though it's your variable, you still want to clear the fraction. But then what's tricky is you don't actually want to distribute, because then you'll have two y's. You'll have a y there and a y there, and you'll have to factor it out. So leave it factored out, but now you can divide both sides by x squared minus 2. I would definitely say on this problem, clearing this fraction is the number one mistake that I see. Just warning you. So y is equal to negative 1 over x squared minus 2. Now, it is possible that you did it in a different order. You just simplified it differently. Maybe you cleared the fraction here and got rid of that negative 1 and put it on the other side. So your answer could look like this. And that's okay too. How do you get that change? Multiply the top by negative 1 and the bottom by negative 1. So both answers are good. And if you're in AP and you're going to take a multiple choice test, you have to recognize that they very well could do it this way. One, because maybe that's just how they did it. They cleared the fraction way up there. Or it could be because they just want to see if you can get from here to here. Right? Number 4, I'm going to multiply both sides by dx. I see an x and a y in my equation, and I know I need to separate the variables. I have dy over y is equal to 2x dx. So this is the special one. If you instinctively did this, that's great. I'm all for that. But then you start to integrate and you add the 1 and you're like, uh-oh, divide by 0. So that's supposed to trigger a giant warning bell in your head. Warning, warning. What does it mean? You can't divide by 0. So when this happens to you, you have to have your mind be programmed to say, oh, that's right. This is a natural log. Okay, you can't do the integral of y to the -1. You actually want to do the integral as dy over y. So at this step, I'm going to integrate. And then you'll have the natural log of the absolute value of y. And this side, I'm not going to show you over step this time, x squared, because it's x squared over 2 and the 2's cancel. We'll give this side the plus c. Now I'm going to go ahead and I'm going to plug this in to find c. And I get natural log. Now, I don't need to write the absolute value. The absolute value of 3 is 3. So the absolute value symbol is unnecessary if the number is positive. Is equal to 0 plus c. So c is the natural log of 3. I'm still not done yet. I need to solve for y. So I have the natural log of the absolute value of y is equal to x squared plus the natural log of 3. So I'm going to exponentiate both sides. Exponentiate both sides. I'm always telling people in pre-calculus, I can't tell you how important pre-calculus is. That's why they call it pre-calculus, because this is something that you learned in pre-calculus, but for a chapter. So I realize I'm bringing back something super old. Okay, so where do people go wrong on this one? They exponentiate each term. You can't do that. You can't just write plus e to the ln of 3. You're exponentiating both sides. And just as a reminder why, if you have e to the 3 is equal to e to the x, then 3 must be equal to x. That's just a given because their exponents have to match. But if you have e to the 3 is equal to the e to the x plus e to the 1, x is not equal to 2. That's not how it works. You only add the exponents when the bases are being multiplied, not added. So do not exponentiate each term. If you have to, write that down. Do not exponentiate each term. So instead, you have to just exponentiate the side. Notice I only wrote e once in black, plus ln of 3. Okay, so this just becomes y. Okay, I have a little secret. I don't really know where the absolute value goes. I know it's not necessary any longer. Just be okay with that. So natural or absolute value of y just becomes y, and then y is equal to e to the x squared plus ln of 3. Okay, this is an acceptable answer. If you put this on a test, I'm going to mark it correct. If you're doing an open-ended problem on the AP exam, you're going to get it correct. But if you are taking a multiple choice test, I guarantee you this answer will not be there. And you need to know how to transform it. Know how to simplify. Honors, your final exam is going to be multiple choice. And AP, of course, you're taking a multiple choice exam. So the way you simplify this is if you have exponents that are being added, that means that their bases are being multiplied, right? X squared times x to the third is x to the fifth. When bases, like bases, are being multiplied, you add their exponents. So I'm undoing it. I have added exponents, so I'm going to rewrite it with multiplied bases. Why would I do that? Because this one simplifies. E to the ln of 3 is just 3. And that way, I can write my final answer as 3e to the x squared. So it'll look very different, and you need to know where that comes from. So again, this is okay. I'll accept it. But for multiple choice, You had better know how to do it this way. Okay. All right. Number 5. So this is the first one that we've had to do a little simplifying first. So I'm going to change it to dy dx is equal to x squared y squared. You can distribute a square. People get this wrong a lot, but this is xy times xy. And using the commutative property, you can do them in any order. I guess it's associative property and commutative at the same time. I'm going to put the two x's together and the two y's together, and then I get x squared, y squared. But it does not work for x plus y. So if you're wondering how to keep them straight, you could actually multiply it out. If you did this, you would realize there's a middle term, 2xy plus y squared. It is not x squared plus y squared. All right, so you got to keep these two concepts straight. X squared or xy, the quantity squared, versus x plus y, the quantity squared. They have two different things going on. Okay, so I'm going to separate my variables. That's always my first job. I'm going to multiply both sides by dx. And simultaneously, I'm going to divide both sides by y squared. I have dy over y squared is equal to x squared dx. I'm going to move this to the top. The only time you want to leave it at the bottom, so after I made that big deal about natural log, I see kids use natural logs all the time on this one. They're like, oh, I see something on the bottom, it's a log. The only time you need a natural log is when it's a single y on the bottom. Anything else gets moved to the top. X squared dx. I integrate. I get y to the negative 1 over negative 1 is equal to x cubed over 3. I can only add c to one side. Let's just add it to the x side because we're used to doing that. All right, just to do something different than I did last time when there was a negative 1 on the bottom, this time I'm going to clear the fraction. You can just move the negative to the top, but there's nothing wrong with putting it on the other side. Totally acceptable. I am going to move this, though, to the bottom. Y to the negative 1 is 1 over y. Is negative x cubed over 3 minus c. I am going to clear the fraction again now that I have it. I'm going to clear it with the y. And that gives me 1 is equal to negative x cubed over 3 minus c times y. So y is equal to 1 over negative x cubed over 3 minus c. I need to plug in my y is equal to 1, x is equal to 1. And I get y is equal to 1 over negative x cubed, so negative 1 cubed minus c. This is terrible. I feel like I could have done it a better way. We'll see. Because my c is stuck here on the bottom. So I'm going to multiply both sides by the negative 1/3 minus c. This side by the negative 1/3 minus c. And I get negative 1/3 minus c is equal to 1. Move the c to the other side. Move the c to the 1 to this side. And I get negative 1/3 minus 1. Negative 4/3 is equal to c. All right, that gives me y is equal to 1 over negative x cubed over 3 minus c. Minus a minus 4/3 becomes a plus 4/3. If there's an open-ended question on the AP exam, don't simplify. Once you have y alone, nobody cares if you have complex fractions. But if you're taking a test for me, I need you to practice that skill, both for because this is not how multiple choice answers will look, and because you need to get good at clearing fractions. So I multiply the top and the bottom by 3, and my final answer is 3 over, distributing that 3 to both of them cancels both of them, 4 minus x cubed. And that's your final answer. So just looking back, if I'd maybe cleared the fraction at this point and multiplied both sides by 3, I would have had a 3c. So the bottom line is it was just ugly. All right, next one. So I am going to put the cosine y on the other side. So this is going to be dy divided by cosine squared y. And what's left if you divide both sides by cosine squared y? So accidentally, sometimes people write 0, but cosine squared over cosine squared is 1. And then, of course, if I multiply both sides by dx, I just get dx. So that's a little bit of a tricky step there. And then the next tricky step is just remembering your integration. You can't integrate something on the denominator like that. And I can't do u substitution. I can't let u be cosine and change this to 1 over u squared, because the du would be sine and I don't have a sine. So this is one of those ones that you should be familiar with. If you bring it to the top, you can make it secant. Oops, I forgot my dy. You can make it secant. And now you can integrate both sides. Secant is on your list of 6. The integral of secant squared is tangent. And the integral of 1 with respect to x is x plus c. Now they did try and make it nice and easy for you by saying 0 and 0. So tangent of 0 is equal to 0 plus c, but tangent of 0 is just 0. So c is equal to 0. In other words, they didn't want you to have to worry about that because this next step is already hard. So the question is, how do you get the y alone? How do you get rid of a tangent? The answer is inverse tangent. That's how you get rid of it. So think about it this way. If I said to you, tangent of y is equal to 1, hopefully you'd say, oh, y is equal to pi fourths. I know that one. So you're good at that concept. But if you didn't know it, if it was something like 1.083, then the question is, how would you do that? Hopefully you would just say, oh, on my calculator, I'll just do inverse tangent of 1.083, and that'll give me the angle. So in this case, people usually see it, but in this case, it's a little bit harder because they're both variables. But that's how you get the y alone, inverse tangent. All right, we have 2 more. Number 7, this one's super tricky. You should really pause your video and see if you can figure it out. And if you can't, of course, you can watch, but you have to separate these variables. So how do you do that? You do that by multiplying them, e to the x times e to the negative y, just like we did in that other problem. When you have like bases that are being multiplied, you get to add their exponents. And some people might have thought, oh, I wrote e to the x over e to the y. That's not only just as good, it's probably better, because now you don't have the negative exponent. So when they're being subtracted, that actually meant that they were originally divided. So now I can clear my fractions. That was the tricky step. I can clear my fractions. I'm going to multiply both sides by the e to the y and by the dx. On this side, that leaves me with e to the y dy. And on this side, I'm left with e to the x dx. Now, do you remember the integral of e to the x dx? It's like one of the best ones ever. It is literally just e to the y and e to the x, which unfortunately also sometimes makes it hard for people. They don't see it. They don't remember that one. Okay, let's go ahead and do our plugging in. So on this step, we're going to have e to the 2 is equal to e to the 0 plus c. Anything to the 0 power is, say it in your head, 1. So c is, okay, this is the first time we got a c with parts. Don't worry about it. That's okay. That's what c is. So now we can go ahead and write our equation. E to the y is equal to e to the x plus c, which is e squared plus 1. How do I get rid of an e? Super important. You need to be able to answer this in your head. Battery, of course. You heard the little beep. To get y alone, ln both sides. Hopefully you said that. But both sides, not each term. Do not fall for that. You can't take the ln of terms. You have to do it of the entire side. ln and ln. What you do to one side, you do to the other. Not you do it to one side 3 times, and this side only once. So ln of e to the y and ln of e to the x plus e squared plus 1. And then on this side, you just get y. And on this side, you get natural log of e to the x plus e squared plus 1. Now I am going to change it to absolute value because I don't know what x is going to be. Actually, I don't really need to. I was going to say in case it comes out to be negative, but e to the x is always going to be a positive number. So this is okay since e to the x plus e squared plus 1 is always greater than 0. Okay. I just realized I made this half absolute value and half parenthesis. Okay. Either one of those is fine. Okay, last practice problem. So the only thing you need to move is this. I know there's a lot going on, and sometimes people move the 4 also, but then you'd have a 4 in the denominator. I really don't want that. So I'm only going to move the square root of y. I'm going to divide both sides by the square root of y. Notice this time I'm not showing you that step. I think you've got that, and I'm also not going to show you the dx on both sides, but I think you got that too. And I am going to change this to y to the negative 1/2. Again, only use natural log if you have dy over just a y. Okay, don't use it for anything else. If this is y squared, y to the 1/2. So sometimes people just see a y in the denominator and they think natural log, but it has to be just a single y. All right, this right side is pretty tricky. You should really stop the video and see if you can figure it out. But of course, if you can't, I will help you with it. So this side is easy. Add 1, divide by 1/2, flip the fraction, 2y to the 1/2. Figure out that right side yet? So you do have to do u substitution, so I am going to do it off to the side. I don't want to do it down here because it will take more steps than what this one is, which is already done. So u is equal to ln of x. Du is equal to 1 over x dx. So I can rewrite this integral as 4u du, which would make it 4u squared over 2, which would make it 2u squared. And now that I'm going to substitute it back, now I can write that as 2 ln of x squared plus c. 2 ln of x squared plus c. Now, you can put the absolute value on it if you want. but it started without it didn't have an absolute value when I started. So I figured that that's not my responsibility to do that, but it's also not wrong if you want to just make sure. All right, I do need to actually find C. So I'm going to go ahead and plug that in. I'm going to change my y to the 1/2 to a square root. 2 square roots of 1 is equal to 2 ln of E squared plus C. This is 2. So I already wrote it down for you. The key to know, natural log of E is equal to 1. If that isn't something that you know, if you're in honors, please put it in your appendix somewhere prominent. If you're an AP, you put that in your head. You are going to have to know that. The natural log of E is 1. So this just becomes 2 plus C, which means C is equal to 0. So I get 2 square roots of y is equal to 2 ln of x, absolute value if you choose, squared plus 0. I can divide both sides by 2, and I get square root of y is equal to ln of x squared. So now this a little tricky for people. This side is squared and this side is square rooted. When you square both sides, right, this side is going to become the natural log of x to the 4th power. And then this side, the square root will go away. So be a little careful there. Okay. All right, that is all the practice problems on separating variables. I want to show you something really, really cool now. So you guys have used this equation. You don't really recognize it for what it is, but this is that the amount that you'll have over time is the principal. They call it y original, but the original principal, e to the rt, right? This is a more generalized formula of something that we use specifically for money. And then you might recognize this one as the amount that you'll have over time is your original amount. So again, your principal times 1 plus r over, and we called it n back in pre-calc. The number of times a year you were compounding, they just say k discrete intervals, but number of times a year times nt. So you're familiar with these two formulas. I'm going to show you how they were derived. For years, you've just accepted them. You could still just accept them, but it is pretty cool. So if y changes at a rate proportional, that means if one thing goes up, the other thing goes up, to the amount present. So if you have the change, if y changes, this is y changing, right? dy dt is y changing at a rate proportional. So when two things are proportional, it's a constant times some amount. So you guys might remember this is when two things are directly proportional. I mean, this is going way back. This is algebra 2 now. Proportional. And then y is equal to k over x is inversely proportional or indirectly proportional. Is that looking at all familiar? I hope so. Okay. So in other words, two things are both going up, with k being how fast they're both going up. But then if y is going up, x is going down, we called that inversely. But if something changes at a rate proportional to the amount originally present, and if we call the amount originally present yo at the start of time, then this is the formula. So I'm going to show you how you can do that using separation of variables. So dy, I'm going to multiply both sides by dt, and I'm going to divide by y, just like we've been doing, right? So I put the y with the y, and I moved the dt to the other side. Now, I'm going to integrate both sides. This side becomes natural log of the absolute value of y, and this side becomes kt. Remember, k is just a constant, t is the variable, plus c. Now I'm going to plug in what they told me. they told me that one of the points is 0, y0. So I'm going to put a 0 in here and a y0 right there. So the natural log, now it's an amount, so it's already positive. I don't need my absolute value. Natural log of y0 is k times 0 plus c. So c is equal to natural log of y0. So now I have my formula, which is natural log, and again, y is an amount, so I don't really need my absolute value, is equal to kt plus the natural log of y0. I need to get y all by itself on both sides. So I'm going to e both sides. I put them in a different color to make sure you realize there's only one e. Don't e each individual term. One e. However, on this side you get y, and on this side, to simplify it, I'm going to break it down into multiplication, because when you multiply like bases, you add their exponents. Why would I do that? So that I could rewrite this as just y0, which is the original amount. And what does that give me? Are you ready for this? I'm so excited. Woohoo! Also known as amount is the principal e to the RT. That's where that came from. You learned it. So totally cool section. If you are in honors, that was really just a fun fact. But all these formulas that you've been using since Algebra 1 or Algebra 2 came from calculus. If you're in calculus, you don't have to have this memorized, but there's no question that they could start you with this information and say, if a rate changes proportional to its original amount, and then you'll have to figure it out. But we'll practice those. So I did put the answers up at the beginning of this video for these next 3 problems. This is really just, can you apply the formula? So this is really pre-calculus. There is 0, are you listening? 0 calculus in these 3 problems. The only reason that this is in calculus is because these formulas are derived from calculus, and that's cool. So you can go ahead and try these 3 on your own, and just go ahead and check the answers. But of course, as usual, I will do them out for you. So the first one is, suppose you deposit $800 in an account that pays 6.3 annual interest. How much will you have 8 years later if the interest is compounded continuously? Remember, continuously is this formula. Oh, the box didn't come out. So the amount that you'll have is the original amount, 800, times e to the r, the rate, remember to change it to a decimal, 0.063 after 8 years. And that will come out to be $1,324.26. The dollar sign goes on the left. Don't forget your comma. For part B, what if it's compounded quarterly? That's when you need this formula. This is when interest is being compounded at k discrete intervals. So the amount that you'll have after time is 800. That's your amount original, that little O. Think of it as amount original. Times 1 plus, again, R is for rate. K is the number of discrete intervals, so quarterly would be 4 intervals. And then KT, for the T in this case is 8 years. And that amount would be $1,319.07. So obviously, continuously compounded is better. A hard-boiled egg at 98 degrees Celsius is put in a pan under running 18 degrees water to cool. So I don't know if you've ever made hard-boiled eggs, but after you take them off the stove, it is your job to put them under cool water. That's how you make them nice. So after 5 minutes, the egg's temperature is found to be 38 degrees. How much longer will it take the egg to reach 20 degrees Celsius. How much longer are you going to have to run it under the water? So to figure this out, we're going to use Newton's law of cooling, which again was derived using calculus, but we just need to use the law. So T stands for the final temperature. This stands for the surrounding temperature. This, as usual, stands for the original temperature, but they don't tell us K. K will vary based on what you're cooling. So if you're cooling a pot roast versus an egg, then it makes a difference. So each item that you're cooling has its own unique K. But we can find K because we've already been given one scenario. We know that after 5 minutes, it was reduced to 38. So let's use that. So its final temperature was 38 when it was surrounded by 18-degree water. It was originally 98. Again, TS is twice in here. Surrounded by 18-degree water. E to the negative K times 5. So after 5 minutes, this is what happened. I can use that information to find K for a hard-boiled egg. So this gives me 20 on this side. This gives me, what is that, 80 on this side, e to the negative 5k. This is going to be 0.25 is equal to e to the negative 5k. I'm going to take the ln of both sides. Natural log of 0.25 is equal to the natural log of e to the negative 5k. By the way, if you had it as 1/4, then the natural log of 1/4 is the natural log of 1 minus the natural log of 4. Natural log of 1 is 0. So you could also use negative natural log of 4, and it would give you the exact same thing. But k is equal to, now I'm going to write 0.277 here, but it's actually a much longer number. Don't round. Store on calculator. This is so important. We're about to use this number for something else. So I know you don't want to write down the whole number, but you need to store the full answer on the calculator. So you've got this number. I didn't show that step, but you had to divide this by -5. But make sure you store that on your calculator. Okay. All right. So now we can do the second half of this problem, which is how much longer will it take for the egg to reach 20? So we want the final temperature to be 20, that it's surrounded by 18. It started at 38, not 98 anymore, because it says how much longer. So starting at the 38, again, surrounded by 18, e to the negative, now I'm going to write 0.277, but you should be using the store on your calculator. T, how much longer? Okay, store as x. All right, and so now you can finish this. This is going to be 2. This is going to be 20 e to the, and I'm just going to call it k because I really want to emphasize that you should store that answer. So 2 divided by 20 is 1/10 e to the negative kt. So I take the ln of both sides. Ln of 1/10 is equal to ln of e to the negative kt. So you're going to get an answer for this, natural log of 1/10. And on this side, you'll have negative kt. So it's going to be the natural log of 1/10, which, by the way, is the same as negative ln of 10, for the same reason as it was over there, if that's better for you, divided by negative k. So again, it's approximately 0.277, but you should use the number that's actually stored on your calculator. And when you do that, you're going to get 8.304 if you truncate. But if you round, since the next number was greater or equal to 5, you could write 8.305. So there's this thing that AP and myself will accept, which is truncating. So truncating is when, if you have 3.6957, truncating is literally just cutting it off. Like, I'm not even going to try and round correctly. I'm afraid I'm going to do it wrong. So I'm just going to truncate to cut off. Or you could round. And both answers are acceptable. So I'm going to box them both. All right, last one for this video. Scientists who use carbon-14 dating use 5,700 years for its half-life. Find the age of a sample in which 10% of the radioactive nuclei originally present have decayed. So the formula that you want to use is up at the top of the problem. It says for half-life problems, we use this where K is the half-life. So the amount, I'm going to say amount final, is equal to the amount original times 1/2 to the T over K, where K is the half-life. So it says that only 10% of the radioactive nuclei originally present have decayed. So your final amount is only 90% of the original amount. I guess I don't need to write out original, just AO will do it. So AO, 90% of AO, because 10% is gone, you have 90% left. And of, 90% of always means times, is equal to AO, 1/2 to the T, that's what we're trying to figure out, how many years, and the half-life is 5,700. I divide both sides by AO, amount original, and it cancels on both sides. So I get 0.9 is equal to 1/2 to the T over 5,700. Now we've done a lot of problems where it's E to the T, and then you take the natural log of both sides. Do you remember what to do if the base is 1/2? You take the log base 1/2. That's how you get rid of, how you get something out of the exponent. Log base 1/2 of 1/2 to the T over 5,700. I know we're going way back to pre-calc, right? But whatever your base is, that's what you take the log of. So when we had y is equal to, or I should say e to the y is equal to 7, we took the natural log of both sides because natural log is really log base e. That's what natural log is. But somebody gave it its own special name, but it's log base e. So log base e of e to the y just makes y. Similarly, log base 1/2 of 1/2 to the T over 5,700 is just T over 5,700. A log base 1/2 undoes a base 1/2. Okay, you can do this on your calculator. Once you get it, you can multiply, don't round, right there when you just take that answer just like it is and multiply both sides by 5,700. And again, we're going to have that truncating issue. So you can have T is equal to 866.417 if you truncate years, or if you write 866.418 because you've rounded, that is also acceptable. Truncating or rounding, both good. Oh, great job. Have a great day, everybody.